Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken, who retired from the University of Albany a bunch of years ago, and Seth's brother Joel. We're here to hopefully show you how to approach studying for the SAT math side and also how to do these actual problems. A good way to approach studying for the Math SAT is to go to Khan Academy and take their course called Digital SAT Practice. The Digital SAT is going to start for people in the United States taking the SAT in the winter of 2024. The SAT people partnered with Khan, and basically they told Khan what's on the test, and Khan made questions to help you prepare for exactly what's on the test. So we are going through these questions one topic by topic. We're going to just be cycling through. Today we are, if you want to see how to get this practice and where we're getting this from, please watch our video dated June 29th, 2023. Today we are going to do the first question on center spread and shape of distributions advanced. We only do the advanced questions because we spend a whole bunch of time discussing the theory and understanding of these things, so then it's presumed that you can go back and use what we talk about and do the easier problems. Okay, without anything else being said, let's start this. Okay, so we're going to see a let's go thing, which means we're just starting the first question on this topic. Okay, let's go. Here we go. Please look at the question, try it yourself, and then come back and we'll do it. We'll go through it. Okay, here we go. We're given a plot there. The area in thousands of square kilometers of 19 countries in East and Southeast Asia are shown in the dot plot. Each value is rounded to the nearest 250,000 square kilometers. China, which has an area of like a lot, was excluded from the data. Fine. If China were included, then which of the following would not change? Oh, wow. So, like, you got to do an annotation here. Give an annotation. China would be like out here, right? China would be somewhere out here. Big number. Huge country. Okay. So if China were included, which of the following would not? Which of the following changes would not occur? Which of the following would not change? The mean area would not increase. The median area would not increase. The range of the areas, well, this, of course. I mean, the range of the areas, of course, would increase because the range is the difference between the smallest and the largest. No, this would occur. The standard deviation, probably the standard deviation would change. Let's see.
Yeah.
So the standard deviation probably would change, wouldn't it?
Yeah.
Yeah. So we could talk about why later. Usually, it's the. No, it has to be. It has to be the median, right? Because the mean is the average of them. The mean, of course, the mean would change. Of course.
Yeah.
The median is the middle number. Now, if you have 19 countries, so let's make 5 countries. 1, 2, 3, 4, 5. If you have 5 countries, the median number is right in the middle. But, wait a second. If now you have, that's between the, but then if you have 6 countries, because you've added, you have an odd number of countries. If you add 20 to it, then you have an even number. And if you have an even number, you have to take the average of the two. So don't we have to check to make sure that the middle number here is somewhere in here where if you take the average doesn't change?
Right? Oh, yeah.
Yeah, we have to be careful. Right. So you have 19. On my attitudes, I'm not that smarter than I am. It's my attitude. If I have a number less than 19, I just write the numbers down. 1, 2, 3, no less than 20. I just write the numbers down. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, let's do it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I know it's a really stupid way of doing it. 1, 2, 3, 4, 5. No, make 4.
So
1,
the
2,
entries
3,
for
4. The
1
middle
through
number is
9
10.
are all the same.
Yeah.
The
So 10.
entries, the next 5, 10 through 14,
10, right.
they're also the
1,
same.
2, 3, 4, 5, 6, 7,
Yeah.
8, 9, 10. Here it is. 10. 10, 10. This is now the median. If we
Yeah.
add another number, then it becomes the average of 10 and 11. This is
Mm.
11. This is 10. It
Yeah.
doesn't matter. You take the average of these
Yeah.
two numbers, you get the same thing.
Yeah.
Okay, the
Yeah.
answer is
Yeah.
median. The answer is median.
Yeah.
Um, So I hope most people understand why the mean changes, because the mean is the average. If you add a big number to a test score, let's say you have an average test score, right, and you add a huge number to it, of course it's going to change your average. The range, of course, it changes because the range is the difference between the smallest and the middle. We went over the median. Now what's that standard deviation thing?
That's the square root of the sum of the squares of the difference between the mean and each value.
So in other words, the standard deviation includes every single value.
Yeah. Yeah.
Right, and because
Yeah.
this number is added
Yeah.
in, and this number
Yeah.
is a big number, it's going to have to change the standard deviation.
Yeah.
The standard deviation is that spread, the idea of the spread of the.
Yeah.
You have a data. You have this.
That is the. No, it's the
measure.
standard. It's not the square root of that. It's the square. Yes, the sum of the squares of difference between the mean and each value.
Oh, so the
and
mean.
That's equal to the. That's equal to the. What is that? The mean of the squares minus the mean squared.
Right. Yeah, that's more advanced.
Yeah.
That's more advanced stuff, which is probably not being beyond than what you need to know.
To solve this problem, the standard deviation is a measure of like how spread out is the data.
Yeah.
And of course, if you add one data point that whose value is a lot bigger than all the other data points, it certainly spreads them out more.
Right. Okay. So I guess let's see how they do it. Clear all drawings. So we say the. By the way, whenever you have this problem, and this is not how you do the problem, but usually it's the median that doesn't change. This problem comes up so many times. Usually the median is the thing that stays the same, but you can't do that. You can't do the problem that way. But okay, here we go. The median area would increase. That is not true. Oh wow, they get into the double negatives here. That is not true. Not true. The median area stays the same.
Mm-hmm.
Okay, let's see. Let's see how they did it. Oh, I see. They say what would increase. I see. The median area would increase. The range of the areas increases. The mean area increases. Standard deviation increases. Okay, let's see how they actually do it, though. Okay, they do it in 3 steps. Okay.
Yeah.
Step 1, the median before China. Oh, we did that. Wow, look at that. Yeah. We got it right. Yeah. The median after China is still that, because adding one value will only shift the median position slightly.
Yeah.
What do you mean slightly? If it's any... What do you mean slightly? It doesn't change at all. When does it say slightly? It says, because adding one value above will only change the median position slightly. Do you understand what they mean?
Well, it changes the median position. If it changes at all, it will increase it. and how much it increases is independent of how big the new, bigger data point is.
Oh, because it's right there. You mean because it's right?
Yeah,
It's still right
yeah,
there. It's still at the 250.
yeah, yeah.
Got it. Yeah. The
Mm.
median. Oh, the median position study. That's what we said. We changed from 10 to 11. But if it's a border point, then it's significant. It just so happens that it's not a border point. Border point
Yeah,
meaning that these two
yeah,
numbers are
yeah.
the same. These two numbers.
Well, you could have, distribution, could have distribution that looks like this. A lot of little points,
Yeah.
a lot of big points. About
Right.
half,
Right.
about half of the population is here. About another half of the population is there. And then you have 1 point here and 1 point here.
Yeah.
And adding a big point, adding big point here might shift
Yeah. You're right on the
the
border. Yeah.
median a
Yeah.
lot.
Yeah. Yeah.
Mm.
But the way I did the median, where you put all the numbers in and you just knock them all down and see which one is the middle. That's a good way to do it. If you have the
That's
numbers are
what,
a reasonable number, you just chop away and
yeah.
very visual.
And they happen to give an example where you get the same unchanged median either if you take the average of the middle two or you take, say, the lower of the middle two.
Right. Exactly. That's right.
Yeah.
That's right.
I don't know. I'm not sure how standard it is that they define the median of a even number of values to be the average of the middle two.
No, that is standard. That is standard.
It is? Oh,
Absolutely. Absolutely. Yeah. Yeah.
oh,
Yeah. Yeah.
okay.
When Seth
Uh,
and I learned math, this topic was not in our high school curriculums.
mm,
So I know I'm very, very weak on this topic. When I took the SAT as an adult in 2016, it
mm.
was this topic that made me the most nervous because I never really learned it in school. So I only picked it up as an adult. So that's why Seth and I are sort of hesitant on this stuff. You see, we don't have the same fluency. You notice we don't really have the same fluency that we do on some of the other stuff. It's good when you learn things young, right?
Mm.
And you don't really learn things as well when you're older. So, like us. Okay, so I guess have a great weekend, everyone. Keep studying for con. In terms of approaches, you really just have to know the definitions of these things. You really have to know what the definition of a mean is. It's the average. Mean is an average. That's A. B is you have to know what the median is. The median is the middle number. The range of a data set is the difference between the smallest and the biggest. And the standard deviation has to do with how spread out the data is. Like if you got, let's say you always get an 80 between an 84 and an 86 on every single test you take, then your standard deviation is very small because there's a small deviation in your test grades. Say you're all over the place. Sometimes you get a 50, sometimes you get a 100, sometimes you get a 60, sometimes you get a 90 and 80. Then there's a huge deviation from your mean, the average of your scores. There's a huge deviation in the mean for all your test scores. So your standard deviation would be larger because you've got a larger spread beyond the around the mean. So that's essentially what standard deviation is. But it's highly dependent on the mean, the average, and it's also highly dependent on every value. So if you make a change to one number, big change to one of the numbers, that will change your standard deviation. Okay, everyone? Seth, anything else?
No, I think we're done for the week.
Done for the week. Okay, hope to see you next week.
One week down.
1 week down. Okay, hope to see you next week. Have a great day, everyone. Bye.